Hey, welcome back everybody. This is just the second part in this little video where in the first video we just wrote a little program that makes this LED blink. The ultimate goal of, make this LED blink on this ESP32 C6 using Thorny and CircuitPython. But this video is the second part, is where we're gonna just create a quick API server on here, so you can hit it with API. And then the third video is where we'll all tie that into Meshtastic and make all of us talk to Meshtastic. So so first let's look at just where we are. We've got the red of a long leg of LED via a 330 ohm resistor connected to D2, and we've got the other side of the LED connected to ground. So on there, and you can use any microcontroller. I'm using this seed ESP32C3 because it has built-in Wi-Fi and it's small. I mean, to see how small that thing is, it's crazy. So looking at the PC, I've modified the program a little bit. I've added a few extra things: socket, pool, Wi-Fi, board, that's always been there always, and digital I/O, that's always been there. So just quickly going through the program that I have here is, it's a network name equals get environment SID VS. So you can hard code your network name in here, but the better way to do it is to put it in a settings.toml file that's on the root file system. I'm just going to show you an example. So it would contain something like whatever you want to call the variable, in this case SID_VS, and that's your Wi-Fi SID, that's your Wi-Fi password, and I made a third one, which is the port. So if you go back in here, is all we're doing is we're setting the variable network name equals whatever the Wi-Fi SID is, whatever the password is. Then we try and connect to the Wi-Fi. Then we print out, this is the Wi-Fi address. Then we set up pin 2, the LED pin 2 on pin 2 and as an output. Then we start the server. So here we're starting the server. These are all standard. Here I'm reading the value of a port from that settings file, and so we're going to start it on port 80. Now at the moment it starts on port 80. To do this properly, you need to run this on port 443 and install SSL and the likes, and you should have a API key and things like that to secure it, but this is just a basic example. So here we can see it binds and then it starts to listen, and it will print out it's listening for connections on port. Whoops, that's still hard-coded 80. We can change that to that, but it doesn't matter. So then all it does is whenever it receives data, it puts it into a buffer, and then what it does, it waits for a connection, then it prints and it gets a connection. Then if you hit LED on, the URL LED on, it will turn the LED on. If you hit LED off, /LED/off, it will turn the LED off, and that's the LED.value equals false. If you don't hit any specific endpoint, it will just going to say, hey, use LED on or use LED off. And then it will respond. This is the header part it responds with. It's going to write HTTP1, so it's an HTTP server. So how all of this runs then is, if I press play over here, we will see that the server starts. It says waiting, connecting to Wi-Fi. Okay, and we can see that it's connected to the Wi-Fi. at this IP address, which again, this is a very important part. You should never put this onto your main Wi-Fi network yet. That SID and password, always create your own separate IoT network, just to be safe. I just use a guest network and I connect to that, and I can delete that network afterwards and it's gone, or I put all my IoT devices on that network. So I'll put a little graphic on how to, what I mean by that. But in any case, it's connected to, it got an IP from the server, and it's bound to port 30 or 192.168.87.30. And we can see I just hit it. I'm just going to use my cell phone over here to give you an idea. I just hit that with my cell phone, and I don't know if that's going to be too bright, but and we can see what it says: welcome, use LED on or use LED off. So if I edit this and I say slash LED slash on, and I hit that, we can see the little LED just turned on. The LED just came on, and it then says the response is LED is now on. So if I go to LED slash, let's go to off, I hit that, you see that the LED turns off. It just turned off there, and now it says the LED is now off. So that's what that little program does at the moment. I can control the LED and control the LED on and off. Very nice. But the problem I really think is, and this is then now really, so that's the API server. It's fairly easy to set up. This code will be on the blog post, and you can just use it, and you can turn things on and off. But where this now gets interesting is, this chip boots up. I don't really want to use the LED for turning it on and off. I want to use the LED for giving me the status of whether it's connected to the Wi-Fi or not. What I mean by that is I want to use the LED to get a status of the board, and not specifically turning it on and off. I know I can do that, but I want to get a status of a board. So I've updated the program, and if we look at it, the CircuitPython application, I've added a function here called flash LED so many times at the interval. So the rest is the same, except I added a exception clause over here that in the Wi-Fi connection section. So it's going to try and connect to the Wi-Fi. If it does successfully connect, it's going to flash the LED 3 times at 1 second intervals. But if an error occurred, it's going to flash it 5 times at 0.2. So let's first try it successfully connecting. Let's run this program. It says connecting to Wi-Fi. And if we see the LED, we can see a failure. It flashed 5 times. It flashed 5 times quickly. So an error occurred. Let me try and connect to the Wi-Fi again. We can see an unknown failure. Now let me fix this. I'm gonna just fix the program and try and run it again. So connecting to Wi-Fi, and we can see the LED flash 5 times quickly. This time it connected successfully, and we can see it flashes 3 times slowly. So now I know it's waiting for connections. Hopefully that makes sense, as I want to use the LED as a status light of what happened with the API server. So if an API server starts up on on this microcontroller, I will see that the LED flashes 3 times slowly. If it fails and it cannot connect, it will flash 5 times quickly. So that gives me immediate feedback. Okay, so that's about it for this video. In the next video, we're now going to take this setup and connect it to Meshtastic. So stay tuned for that video. Thank you.